Hello, Algebra 2. To start out Chapter 5, we're going to be looking at variation functions. So direct, inverse, joint, and combined variation. Here we go. The first type of variation we're looking at is direct variation. You maybe have already seen the term proportional relationship. That is exactly what we're doing here. It's just another name for it. The equation can be generally written as y equals something times x. We're always going to use k for our something here. This is going to be a constant number in the equation. So first one, y varies directly as x, and y equals 27 when x equals 6. So write and graph the direct variation function. We don't know yet what k is. We don't know that constant term, but we do know that when y is 27, we know that x is 6. So I can rewrite it like this. And then I could divide both sides by 6, and I could find k to be 4.5. So I would rewrite this then as y equals 4.5x. When I graph it, I'll make a table of values here. This one, the numbers work out pretty nicely, and I get a nice straight line, which is what I would expect. The slope of this line is going to be 4.5. In this example, the cost of an item in euros E varies directly as the cost of the item in dollars D. So there's two different ways we can do this. The first one is to find K like we just did. I wrote down our general form for direct variation, but here I substituted in the variables that were written here. E varies directly as D, so it would be written like this. Now I substitute in what I know. When E is 3.85, D is 5. So I could find K, divide both sides by 5. And I get k to be 0.77. So that means my equation can now be written as E equals 0.77d. And this last part, what is d when E is 10? So I plug in 10 for E and solve for d. And rounding to 2 decimal places, I get 12.99 for d. So that means 10 euros is the same as $12.99. The other way you could do this is to use a proportion. So I'm going to set up euros over dollars. So 3.85 euros is $5. So that's going to be equal to 10 euros over I don't know how many dollars. And now I'm just going to solve this for d. To get d out of the denominator, I multiplied both sides by d. And then on this side, I just took 385 divided by 5, and I got 0.77. So now to get d by itself, I'll just divide. And you notice it ends up being the same division we just did. And so we get the same answer for d. Next type of variation is joint variation, which just means that we have more than one variable that are varying directly. So it's the same type of equation, just with more than one variable. So here we have the volume of a cone, V, varies jointly as the area of the base and the height. So I'm going to start by just writing down the general equation for joint variation. And then I'm going to fill in the variables that we're using here. So V for volume varies jointly. So I still have K, I don't know what that is. But it varies jointly as the area of the base, capital B, and the height, H. So now I'll fill in what I know from this line right here. When the volume is 12, that means the base is 9 and the height is 4. So from here, I could figure out what K is. So down here, I figured out K to be 1/3. So now I'm going to use that again. So I write down my general equation here, fill in what I know for this last part. I want to find B when volume is 24 and the height is 9. And I'm using 1/3 for K. So now I just have to solve for B. And when I solve this, I get the area of the base to be 8. A good rule of thumb here is that you're going to use some of the information they give you to find K, and then you'll use that again to find the value that you're looking for. Now we're looking at indirect variation, which is going to have this general form of an equation right here. Notice that in this one, your x is in the denominator, and that's always going to be true for an inverse variation. So down here, we know that y varies inversely as x. So I'm going to write down our general form here. And we know that y is 4 when x is 5. So from this, I need to find k. I would multiply both sides by 5, and I would get k to be 20. So now my general equation I'm looking at is y equals 20 divided by x. When I put my values into the table and I plot them, you end up getting this graph with 2 pieces and 2 curves, and it looks like this. We'll talk more about the asymptotes and everything of these graphs later on in the chapter, but this just gives you an idea of what that graph looks like. In this example, the time needed to complete a certain race varies inversely. So here's my general inverse function variation. And it varies inversely as the runner's average speed s. So I'm going to replace this with the variables that we're using for time and speed. If a runner with an average speed of 8.82, so that's going to be in our denominator right here, completes the race in 2.97 hours, what is the average speed of a runner who completes the race in 3.5 hours? So first thing I need to do here is find k. And I got k to be 26.2, rounding, or 20, rounding to 2 decimal places. So now I'm going to use that over here, and I'm going to figure out what is the average speed of a runner who completes the race in 3.5 hours. So I'm going to put in 3.5 for t, and I'm going to solve that for s. I'm going to get s out of the denominator by multiplying both sides by s. So I have s times 3.5 equals 26.2, and divide both sides by 3.5. Rounded to 2 decimals, it would be 7.49 hours. On this slide, we're just looking at the difference in direct and inverse variation if we solve the general form for k. So if we solve for k here, or divide both sides by x, we get this. So k is going to equal y divided by x. If it's true direct variation, then that is going to be a constant ratio there. In inverse variation, to get k by itself, I'd multiply both sides by x. So you get k equals x times y. And if it's true inverse variation, then this is going to be a constant product. Here we're going to try to figure out, are these direct or indirect variation? So what I'm looking for is, again, if it's direct variation, y divided by x is going to be a constant number. So in A, I'm thinking y divided by x. Well, here it's going to be more than 1. Here, y divided by x is going to be less than 1. So that's not it. If it's indirect variation, x times y is going to be a constant number. And in this first one, x times y for each of these pairs ends up equaling 52. So that is going to be indirect variation. In B, I'm going to try direct variation again. I'm looking for y divided by x to be the same number. 30 divided by 5 is 6. 48 divided by 8 is 6. 72 divided by 12 is 6. And so this is direct variation. Combined variation is something that includes both direct and inverse variation. So here's an example. This would be that y varies directly with x, because that's in the numerator, and inversely with z, so that would be in the denominator. So you have multiple things happening in the same equation. So how we read through these problems is really important, so let's start with this one. The change in temperature of an aluminum wire varies inversely. So my temperature is going to vary inversely as its mass, m, so that's going to be in the denominator, and directly as the amount of heat energy, E, transferred. And I'm still going to have a k here, because that's still going to be my constant term that I have to figure out. My next sentence, starting right here, is going to give me some information I can use. The temperature of an aluminum wire with a mass of 0.1 kilograms, that's in the denominator, rises 5 degrees, that's my change in my temperature, when 450 joules of heat energy are transferred to it. So I can use all that information to solve for k. When I solve all of this for k, I get k to be 1/900th. So now I'm rewriting my equation with k in there as 1/900th. To simplify, I could rewrite this as just E over 900 m. And I'm going to use the information in this last part. Mass is 0.2 kilograms. I want to raise the temperature 20 degrees Celsius. So how much energy? So 20 is going to be my T. I'm looking for E, 900 times 0.2. So I'm going to solve that for E. So when I solve this for E, I get E to be 3,600, and that label on that would be joules.